In this video, we're going to take things a step further by introducing all of the standard and advanced mates available in SOLIDWORKS, giving you a more complete understanding of how parts can interact within an assembly. We only introduced a few mate types in the last video, so let's now look at a complete list of all the standard mates and explain what they do. Coincident aligns two entities so their surfaces lie on the same plane. This is perfect for placing a component flush against another surface. Concentric aligns cylindrical faces so their centers match, ideal for inserting shafts into holes or arranging nuts, bolts and washers. Parallel keeps two faces or edges running in the same direction, even if they're not touching. Perpendicular forces two surfaces to meet at a 90-degree angle. Tangent keeps a curved face in contact with a flat or another curved face. This can be useful for positioning rollers, for example. Distance defines a set gap between two entities, allowing controlled spacing. And angle maintains a specific angle between planar faces, edges or planes. These standard mates are simple to apply and cover most everyday positioning needs. Let's look at a quick example to see how some of these standard mates work together. I'll continue with the example that we used in the last two videos. There are already some mates in place, two coincidents and a concentric mate. These all position the cylinder relative to the plate. I'm going to bring in this gusset, which is used to brace the cylinder. The first mate I'm going to add is a coincident mate that aligns the underside of the gusset with the top face of the plate. I also want the back face of the gusset to touch the cylinder, and the mate type I can use to achieve this is the tangent mate. I introduced adding mates to planes in the last video, and we'll do the same again here. Now let's move on to the advanced mate types, which allow for a more controlled relationship between parts. Symmetric keeps two components evenly spaced about a plane or planar face. This is great for keeping components balanced on either side of an axis. Width mate centers a part between two faces. For example, it can keep a slider centered within a track. Path mate constrains a point on a component to follow a predefined path or curve. Great for cams, slots or guide rails. Linear coupler mate links the motion of one component with another. For example, when one part moves forward, another moves backwards at a set ratio. Limit distance mate allows movement between two selections, but only within a defined range. For example, allowing a drawer to slide open, but controlling by how far. And limit angle mate functions similarly but for rotation. You might use this to restrict a hinge to swing only between 0 and 90 degrees, for example. Advanced mates are especially useful when your design requires specific movement, centering or limiting of motion, giving your assemblies a more realistic and functional behaviour. The width mate is a really useful mate type and removes the need to manually calculate distances between parts in order to position them. I'll bring in this ring that is going to sit over the cylinder. The first mate I'll add is a concentric, in order to align the axis of the two parts. If I now drag the ring, you can see that it is free to move up and down the main cylinder, but I would like it to be equally spaced between the top and the bottom of the cylinder too. This is where the width mate can be used. In the mate dialog, with the width mate selected, I'll select the top face and the underside face of the ring, and in the second box, the top face of the cylinder and the top face of the plate. I can use the top face of the plate as it is in the same position as the underside face of the cylinder. This centralizes the ring to be in the middle of the cylinder. The benefit of using this mate type is that if the cylinder changes length, or the depth of the ring changes, the two will always be aligned from the center. So now you've seen how both standard and advanced mates work, and how they can be used to control positioning and simulate real-world behavior. We're going to move away from mates in the next video and introduce you to some assembly level features, such as patterns and evaluation tools. So we'll see you there next. And if you need to create marketing material and assembly instructions, why not try Cadacio? Turn your SOLIDWORKS files into interactive 3D presentations that you can share online. Sign up today and try for free at cadacio.com.